Welcome to Patrick Talks Teaching. Today's topic in the world of math is going to be exponents. We'll take a look at all the rules that apply to them and what exactly exponents are. At school, our math journey sort of looks like a staircase depicted here. We begin learning about addition. Once we've mastered addition, we progress up to multiplication, which is repeated addition. After that, we get exponents, which is repeated multiplication. So let's look at this in terms of contexts and examples. Addition's a pretty simple place to start. We can look at questions back in the day like 2 plus 3, which equals 5. We're finding the sum of two numbers, or more. Afterwards, we make a connection that addition and multiplication have something in common. Multiplication is going to be repeated addition. So let's take 2 plus 2 plus 2, which is the same thing as saying 2 times 3. Well, now we make a connection from multiplication to exponents. Exponents are just repeated multiplication. So let's say we have a question now that would involve something like 2 times 2 times 2. So we're multiplying the number 2 3 times, and that's going to look like 2 to the exponent of 3. So let's take a look at this exponent in a little bit more detail. Let's take the question 2 to the exponent of 4. Now, there are a few pieces to the puzzle here that we can name. The base is your 2. It's the big number that we're doing the repeated multiplication with. This number up here is the exponent, which is the number of times that we multiply the base by itself. Together, these two things are called a power. When it's written like this, it's called exponential notation. When I expand it out like this, 2 times 2 times 2 times 2, that's expanded notation. Both meaning the same thing, but it's expanded notation that allow us to see the repeated multiplication. Let's look at some questions. Our first example, we have the same base, but some different exponents, and that dot in the middle means they're being multiplied together. If I expand this first one, we have 2 times 2 times 2, 3 times. We're going to multiply it by the same base, but multiply by itself 4 times, 2 times 2 times 2 times 2. Now when I add these all up, since we're doing just repeated multiplication, notice that we're actually multiplying the number 2 by itself 7 times. So our final answer is 2 to the 7. Notice by adding those exponents, 3 and 4, we get the 7. So as long as our base is the same, when they're being multiplied together, just add the exponents. Here's another question, this time division. Now I always like to think of division as a fraction. In fact, if you look at the division sign, it sort of looks like a fraction. We have 2 to the 4 on top, divided by 2 to the 2 on the bottom. Numerator and denominator kind of make the two dots that you see in that division sign. Now if I expand this out, we have 4 2's being multiplied together on the top, and we're dividing it by 2 2's in the bottom. Now 2 divided by 2 is just 1, so we can cancel anything out that's the same on the top and bottom. And when we rewrite our answer, we end up with 2 2's left on top, so that's 2 to the 2. And notice that if we're dividing and we have the same base, we could subtract our exponents, and that's an easy way to get to our answer. Let's take a look at one more question. Those negative exponents can be very confusing, one of the evils of math that we always want to get rid of. I'm going to be a little sneaky here. I'm going to make a division question where the answer is -2, using our subtraction rule we came up with before. So if I have x to the 2 and I divide it by x to the 4, I already know that if I subtract the exponents, 2 minus 4, that's the same thing, x to the -2. So let's expand this one and make another fraction to represent what we have. We have 2 x's in the numerator, and we're going to divide it by 4 x's in the denominator. We once again cancel out whatever we have in the top and bottom, and take a look at what we have left with. We have 2 x's on the bottom. I have to keep in 1 in the numerator because we can't have nothing there. So that's the same as 1 over x squared. So notice that the answer to our question, x to the 2 divided by x to the 4 is x to the -2, which is also the same thing as 1 over x to the 2, or x squared. So this negative exponent is telling us to take the reciprocal. Our x to the -2 was in the numerator, but now we're going to flip it to the denominator. That is the reciprocal. And notice by doing that, we also change the sign. So there you have it, some quick rules and reasonings as to what we can do with exponents, which are just repeated multiplication. They're just the next step up on our mathematical staircase. Till next time.